Okay, let's unpack this. Imagine working deep underground,
Yeah.
right? Operating huge machinery
Yeah.
or navigating complex safety protocols. I mean, it's an environment where one wrong move can have, well, severe consequences.
Absolutely. A really high-risk world.
So training in this world, the world of mining, it's just not about reading a manual, is it?
No, not at all.
It's about mastering incredibly complex tasks safely,
Mm-hmm.
often in conditions that are, inherently dangerous.
Mm-hmm.
Traditionally, that's meant a lot of hands-on training, which, while essential, has some pretty significant limitations when you think about risk
Right.
and accessibility.
Absolutely. You're dealing with environments where the cost of error is just extremely high.
Yeah,
Getting truly realistic practice without putting anyone in harm's way is, well, it's a fundamental challenge for the industry.
exactly. And we're also seeing industries everywhere embracing digitalization and the fourth industrial revolution, 4IR,
Mm-hmm. It's everywhere now.
And mining is absolutely part of that trend. This shift naturally pushes companies to look for new ways to train, new technologies to bridge that gap.
And while there's a lot of talk about VR in the context of 4IR in mining,
Yeah, you hear a lot.
practical, impactful examples that go beyond just being like a novelty have, well, according to the source material you've provided, they've been somewhat few and far between.
Yeah.
It seems like implementing truly effective immersive tech for high-stakes training has been a bit of a hurdle.
Right, finding practical, impactful solutions is the key. And that brings us to the focus of our deep dive today, a company called Stas 3D.
Ah, yes.
They're applying virtual reality and specifically something they call tactile VR, which is VR with a sense of touch,
It's just fascinating.
to really revolutionize how training is done in the mining and metals sector.
And based on the sources, their approach seems built on deep collaboration.
Okay.
They work directly with top experts in mining methods, rock engineering, safety.
The people who really know.
Exactly, to truly understand the complex challenges involved. That lets them build simulations that address those real-world problems directly.
So our mission for this deep dive then is to unpack their specific approach, try to understand the science and methodology they use to create these truly immersive learning solutions. And look at the real-world results they're reporting. We want to understand how VR is evolving beyond just gaming,
Right, becoming a serious tool.
to become this powerful, practical tool for critical skills training in demanding, high-risk environments.
Okay, so let's jump in with the core problem they identify and the solution they propose.
Yeah.
That gap we mentioned earlier, the need for practical, proven application of 4IR tech, specifically for workforce training. Lexstress 3D seems to position themselves as directly addressing this.
And their key innovation, the thing that really makes them stand out in the sources, is this focus on tactile VR training.
That tactile element.
It's not just about seeing in VR.
Yeah.
It's about adding that crucial sense of touch, that physical interaction.
Yeah, and that sense of touch is critical.
Yeah.
The source material highlights that with the latest VR headsets providing an uncanny sense of realism,
Right.
that feeling of being there, adding tactile feedback, makes the simulation the closest thing you can get to real or on-the-job training.
Because then it's not just theoretical knowledge, is it?
Not at all.
You're actually interacting physically, manipulating controls, getting that muscle memory built.
Exact.
The sources talk about rapidly imparting psychomotor skills.
Yeah.
That's basically the connection between your brain and your muscles for complex movements. Things like handling vehicle controls, remote machinery, complex bolting, support installation, drilling deep underground. It's true learn by doing.
And what's fascinating here is how they achieve that sense of realism and impact. It's not just, throwing VR technology at the problem.
Right.
Their definition of immersive learning is actually a very specific blend of disciplines.
Okay, what's in the mix?
Virtual reality technology, obviously, combined with instructional design, neuroscience, and visual storytelling, and also game simulation principles and safety science.
Wow, that seems like a really unusual mix. Neuroscience with game design. How do those even work together to create training?
That's the magic, isn't it? This specific combination is designed to produce a strong sense of presence, that feeling like you are actually in the underground environment.
Okay.
Along with a level of bodily interaction and mental engagement that is absolutely ideal for learn by doing.
Right.
And crucially, when you interact in their virtual world, You activate the same neural pathways in your brain that you would use in the physical world.
So your brain is essentially treating it like a real experience,
Yeah.
which makes the learning stick better.
Precisely.
Like real-world practice, but without the risk.
Exactly. The brain is fooled, you could say, in the
Yeah.
best possible way. And the training software is designed to track your performance using assessment data and capture client feedback to measure how this virtual practice is actually translating into improved performance back in the real world.
That makes perfect sense. And it leads us right into the tangible results they report.
Yeah.
This is where it gets really interesting because they aren't just saying it feels realistic. They're claiming measurable business and safety impact.
They feature some pretty compelling quotes in the source material that back this up.
Like what?
For instance, Selby Gabella, HRD manager at Amandelbolt, Anglo-American Platinum, is quoted saying, 35% production improvement within 90 days, mainly due to us training shift bosses and miners on marking and blasting in the SUFT's 3D VR stope.
35% production improvement. In just 90 days.
Yeah.
That's a huge leap. It shows this isn't just some, training exercise. It's directly impacting operational efficiency.
Absolutely.
Why do you think that specific training, marking and blasting in VR, led to such a dramatic result?
Well, the source suggests it's because marking and blasting is such a critical, complex task.
Okay.
It directly impacts the quality of the rock breakage and, therefore, the efficiency of the whole mining cycle.
Right.
So, mastering the precise steps, the spatial judgment for marking, understanding the sequence for blasting, doing that in a highly realistic virtual environment where mistakes can be safely made and corrected, that likely leads to much faster skill acquisition and retention than traditional methods.
Yeah, that makes sense.
It's taking a high-impact, complex task and making it accessible for focused practice.
That totally tracks.
Yeah.
Practice in a safe, realistic space before doing it for real.
Okay, what about training time? Did they mention that?
They did. Another result they quote comes from the BlackRock Manganese HRD department. The VR used in the Expert Miner program is super realistic. The best training experience ever. We now train 4 times quicker than before.
4 times quicker.
Yeah.
Wow.
Yeah.
Think about the cost savings and the speed at which you can get skilled workers into the field. That's massive efficiency. It really is. And Tony Pretorius, executive at Murray & Roberts Training Academy, speaks to a key logistical and competitive advantage.
Oh.
He says, "We are now deploying a portable VR drill rig developed by our strategic technology partner, 3DC.
A portable rig.
Yeah. We now easily transport this groundbreaking training tool in a purpose-designed trailer to wherever our mine clients would like to have it deployed, even underground."
Wow, even underground.
He adds, "This provides us a specialized, mechanized training provider with a massive competitive advantage."
Wow, the ability to take the entire training rig underground, right to where the work happens, that removes huge logistical barriers.
Totally.
Makes training incredibly flexible. These results really hammer home the practical, measurable impact they're claiming for their approach.
And these results don't just happen by accident, right?
No, I guess not.
Let's dig a little deeper into the principles that guide their program design because they structure their learning experiences with clear objectives in mind.
Okay, what are those guiding principles?
First, they aim to make learning easy.
Easy. How so?
That means making the content, the digital tools, the media emotionally engaging, simple to understand, easy to use, and immediately applicable, just accessible.
Okay, so accessible and engaging makes sense. And second,
Provide context. They use stories that resonate with the learner's actual working experience and their aspirations.
so it feels relevant.
Exactly. If the training feels relevant to your daily challenges and career goals, you're much more likely to engage with it.
That makes sense, making it personal.
Yeah.
And the third principle?
Show cause and consequence. This is particularly important in mining, obviously.
Yeah.
They don't just show you how to operate equipment. They simulate the interaction between people, equipment, and hazards in lifelike environments.
Okay.
They also dig deeper, as the source puts it, showing the motivational biases and dilemmas people face when making tough decisions under pressure underground.
So it's not just the technical skill.
Right.
Yeah.
It's not just about the technical action. It's about the human element and the real outcomes of choices.
That connects the physical skill to the critical thinking and decision-making that is so crucial in a dangerous job. You see why following procedure matters.
Exactly.
What's the final principle?
Promote practical problem solving. This goes right back to experiential learning, or learn by doing, using that tactile VR. It's about mastering those psychomotor skills and building muscle memory. Their simulations also promote pattern recognition and analytical skills
Right.
by exposing learners to varying scenarios and increasing complexity, using repetition to build fluency and confidence.
So it's a layered approach then.
Sure.
Make it easy and engaging, connect it to the learner's real world through stories, show the direct impact of actions and decisions, and then build practical skills through realistic, repeatable practice.
You got it. That's the idea. And the success of that structure is built on the core components we mentioned earlier, that specific blend of disciplines.
Right, the VR, neuroscience, game design.
Exactly. Let's break those down further, starting with how they leverage virtual reality itself.
Okay, you mentioned connected presence.
Ah.
How does that feel to the learner? What is that exactly?
Think about putting on the VR headset and suddenly feeling like you are actually there in the underground stope or actually inside the cab of a massive piece of machinery.
Wow.
That's connected presence, putting the learner in a lifelike situation which triggers realistic emotional responses, just as if they were physically there.
Okay, so it feels real, which ties into realistic perception and activating those same neural pathways you mentioned earlier.
Precisely. The visual and physical realism of the interaction means your brain processes it very similarly to a real-world experience. It's learning through genuine sensory input and physical action.
And real-time feedback. Is that where the tactile VR really shines?
Absolutely. This is where the tactile VR and physical controls come in. You're not just watching, you're physically operating realistic controls, levers, buttons, joysticks.
Right, you're doing it.
That physical interaction, combined with instant feedback from the simulation, whether it's the feeling of a control engaging or a visual reaction in the virtual world, significantly increases learner engagement and retention compared to passive learning. You feel the consequence of your actions.
And bodily engagement. What's that?
That refers to the full body involvement. You're making real-world decisions using physical actions, your hands, your body position within the virtual environment, and getting that real-time physical feedback. This directly contributes to building accumulated experience, even though it's simulated. It's muscle memory reinforced by realistic interaction.
Okay, that makes the VR side clear. It's about making it feel as real and physically engaging as possible. Now, how does instructional design optimize learning within this powerful environment?
Well, it starts by reinforcing that learn by doing principle, ensuring the physical movement and mental engagement in VR help build and strengthen the right brain connections for the task.
Right.
They use a structured approach, sequential, step-by-step job instructions. The simulation guides you through the process, showing the what to do, how to do it, and importantly, WHY, it's done that way.
The why is key.
All in simple, clear language.
So it breaks down complex tasks into manageable steps, makes it less overwhelming.
Exactly. And then there's repetition to embed muscle memory. VR makes on-demand learning really easy, allowing learners to practice the same task multiple times.
Right, you just do it again and again.
Frequent repetition, ideally with slight variations, is key to building fluency and confidence, turning conscious effort into automatic muscle memory.
Like practicing a musical instrument or a sport, kind of.
Precisely that kind of idea.
Yeah.
And finally, increasing complexity. As the learner gets more comfortable, the simulation exposes them to progressively harder challenges.
Okay.
Less ideal conditions, unexpected hazards, and opportunities to make and learn from critical errors.
Ah, so it ramps up.
Yeah. This enhances knowledge transfer and long-term retention, preparing them for the unpredictable nature of real-world work.
Now, the visual storytelling and neuroscience part is particularly fascinating. You mentioned that. How do they use brain science to make the training stick?
This is really interesting stuff. What's truly fascinating here is the research they draw on. For instance, the source mentions that storytelling makes facts 20 times more likely to be remembered than just presenting information.
20 times.
Yeah, why? Because stories triggered the release of chemicals in the brain, like cortisol, which helps encode memories, and oxytocin, which creates empathy and connection. Narration in the simulation activates specific parts of the brain, prompting listeners to internalize the story perhaps of an incident or a successful procedure as if it were their own experience.
So they're not just showing you a procedure, they're weaving it into a narrative that your brain is basically wired to remember and emotionally connect with.
Exactly. And arousal and affect are also important. Emotional responses like a brief moment of stress when facing a hazard, surprise at an unexpected event, or a sense of accomplishment when completing a task correctly make the training more memorable.
Right. Emotions help things stick.
Definitely. They use principles like DIPI, that's danger, importance, positive outcome, interesting detail to structure scenes for safety training,
Oh.
ensuring key safety messages are delivered with emotional impact. And ARCS, attention, relevance, confidence, satisfaction for experiential learning, keeping learners engaged and motivated.
Okay, so DIPI and ARCS are frameworks for structuring the emotional and motivational aspects of the training, kind of like design guides.
Precisely.
Um,
And decision-making learning sticks particularly well because the brain releases dopamine after a correct response.
that reward chemical.
Yeah, that little hit of positive reinforcement helps embed the learning pathway for good decision-making.
It sounds like they're consciously designing these experiences to, like, hack the brain's learning mechanisms.
I think that's a fair way to put it. They are. And finally, visual hierarchy and cues. Using things like form, color, depth, and motion directs the learner's attention in the virtual environment. They also use icons and visual cues to link the virtual world back to the real one the learners are familiar with, reinforcing the relevance.
This really shows how intentionally they're designing these experiences, doesn't it?
Yeah.
Leveraging a deep understanding of how people actually learn, not just using tech for tech's sake.
Exactly. And that brings us to the fourth component, simulation games and safety science.
Okay.
The source indicates that training based on simulation games provides much better retention than instructional methods,
Right.
with a reported improvement of 20% in self-efficacy.
So people feel 20% more capable after game-based simulation training. That confidence must be huge, especially in a high-risk job.
It is, absolutely. And this is deeply integrated with safety science principles. They say safety science follows 4 tenets: relentlessly identify hazards, positively reinforce standards, conduct independent checks, and crucially, learn from errors and incidents.
And they weave critical safety learning into everything, drawing on those tenets. It's not just a separate safety module.
Right. Safety isn't a separate module, it's embedded. They focus on practical safety concepts like root cause analysis after an incident, recognizing near misses before they become accidents, understanding leading indicators of risk, and promoting reflective safety conversations among teams.
How do they track attention and provide feedback in these simulations? It must be more than just like a test at the end.
Exactly. They use attention tracking, monitoring head movement, eye tracking, physical interactions, clicks to see what the learner's focusing on and what they're doing.
Oh, yeah.
They provide instant visual assessments, giving learners immediate feedback within the simulation itself. Did you miss a hazard? Did you perform a step incorrectly? You know right away,
Right in the moment.
which shortens the learning cycle and helps correct mistakes in the moment.
It's clear they have a really sophisticated methodology blending tech, design, psychology, and safety principles. But their offering seems to go beyond just creating simulations themselves.
It absolutely does. The sources present them as more than just a VR development shop. They offer services like advising clients on digital training solutions, working as a strategic partner, for instance, with Murray and Roberts Training Academy.
We heard from them earlier.
Right. And they draw on a network of academic and research partners like universities and the Mandela Mining Precinct.
And they don't just design the software. They're involved in manufacturing specialized gear, too. You mentioned the portable rig.
Yes, they have engineering and robotics expertise to manufacture custom equipment simulators, motion platforms, projection frames for larger VR experiences. And they source specialized VR gear like headsets, sensors, haptic gloves, or even AR wearables tailored for industrial use.
Okay.
This allows them to create highly specific, realistic physical interfaces for the simulations.
That makes sense. Building the custom hardware needed for that tactile VR experience. And they design VR learning centers. What's that about?
They have experience doing this for universities and companies like Anglo-American and Thorncliffe Mine. Their philosophy here focuses specifically on learner-centered design, creating spaces optimized for how people learn best, using visual techniques, encouraging peer-to-peer learning, supporting self-learning, and designing the physical space and equipment layout to facilitate shared learning experiences.
Oh, it's about creating the right physical environment to maximize the effectiveness of the digital training. Interesting. And they offer facilitation services.
Yeah, they've been doing computer-based training facilitation since 2005 and develop comprehensive train-the-trainer material so organizations can deliver the training themselves if they want to.
Right. Building capacity. And they have their own platform, the Extended Reality Platform, or XRS. What does that do?
That's their central content and learning management platform. It's kind of the hub connecting all their digital tools, the tactile simulators, projected VR setups, e-learning games.
Got it.
It includes modules for managing learning progress, content distribution, contractor management, integrating group training sessions, and it can interface with clients' existing systems.
A major feature mentioned is the XRS Content Builder. What does that allow clients to do? That sounds powerful.
That's a big one for giving clients control. It allows them to build their own content, create or edit simulation scenes, configure specific training curricula, and manage versions of their training materials.
Oh,
It gives organizations a lot of flexibility and ownership over their digital training assets. They also use the platform for digitalizing contractor onboarding processes,
okay.
making it more efficient and ensuring compliance and resource management.
So they really offer a whole ecosystem around immersive training, don't they? From strategy and custom hardware to content creation tools and a management platform.
Seems like it.
Let's look at some specific product examples mentioned in the sources to see this in action. Make it a bit more concrete.
Sure. One major area is rock engineering and geological conditions. This addresses a critical safety risk in mining falls of ground.
Right, a huge danger.
They have learning solutions covering things like interactive 3D presentations of geological structures, demonstrating support methods, and extensive programs built around TARP management.
What's TARP managed?
Good question. TARP stands for Trigger Action Response Plan.
Okay.
In mining, it's a critical system for managing risks like ground falls by defining specific conditions. Those are the triggers that workers must look for, and the mandatory actions they must take when those conditions are observed. Their training includes VR entry exams on TARP, 3D hazard identification simulations, practicing safety conversations, and even supporting materials like games and posters to reinforce these vital safety procedures.
Wow.
They've implemented this for over 25 clients, which highlights its importance.
Okay, so using VR to make complex safety plans like TARP tangible and actionable, that makes sense. Another area is learning from incidents, or LFI. This raises an important question. The source mentions traditional incident reports aren't enough. Why is that? What's wrong with them?
Yeah, the source material is quite clear on this, and it's a powerful point. Traditional reports are often too wordy, too complicated.
Right.
They're one-way communication, and frankly, easily forgotten. People learn best from stories and shared experiences, not dry reports. To truly learn from an incident, people need to actively reflect and make a personal decision about how that incident applies to them and their own work.
Yeah.
Simply reading about someone else's mistake isn't enough. They have to engage with it and make up their own minds, as the source puts it.
So how did their simulations address that? How do they make it personal?
They have two main formats based on the same incident data. Incident reconstruction simulations, or IRS, are typically for executives and managers.
Okay.
These provide a factual, sequential account of what happened in a realistic virtual environment to ensure everyone at a senior level has a shared understanding and can appreciate the real-world constraints faced by managers underground.
Right, getting everyone on the same page factually. And the learning from incidents, the LFIs for the workforce. How are they different?
These are designed specifically for supervisors and the general workforce to convey the lessons learned from real events. They don't just recount facts. They link the incident lessons to common deviations they might see every day, like taking shortcuts, failing to report near misses, or using poor techniques.
Ah, making it relatable.
Exactly. They use storytelling with emotional content, metaphors, and even graphic sketches to make the incident relatable and impactful. The goal is reflective learning, encouraging personal anecdotes about real dilemmas like balancing production pressure versus safety, and including assessment questions to prompt critical thinking and ensure understanding.
That sounds dramatically more effective at getting the message across than just distributing a PDF report.
It's certainly designed to be. They also have collections of safety protocols covering a wide range of occupational procedures, over 25 mentioned, with more than 500 interactive hazard scenes.
Wow.
Productivity simulations using lean management principles to optimize things like flow, cycle times, logistics like ventilation, traffic, or evacuation. Leadership tools designed to model effective supervisor behavior in using management tools like pre-shift meetings or job safety analyses, JSAs for team safety and problem solving. And induction programs that include exciting VR tours and web-based XRS options for remote completion before even arriving on site.
It's clear this company has been in the immersive training space for quite a while, starting well before the current VR hype cycle. The source briefly touches on their story and philosophy.
Yes, they started way back in 2005, specifically challenged by Anglo-American Platinum to find better ways to prevent falls of ground fatalities,
Right.
which are tragically a significant risk in mining.
So their very origin is tied directly to addressing a critical safety issue. That's fundamental to who they are.
Absolutely. Their core ambition is stated as to help make mining safer with immersive learning solutions.
And their aim, what are they trying to achieve with these solutions?
To reinvent training using VR and digital tech for solutions with impact, focusing on achieving real results across cognitive, which is knowledge, affective, so emotional buy-in, attitude,
Right.
and psychomotor learning domains. That's the skill, the muscle memory, making it interactive, emotionally engaging, and truly user-friendly.
And their ultimate goal as a company.
The source says it's to make lifelong clients and help those clients become digital champions themselves, integrating this technology effectively into their operations.
Empowering the clients.
Guided by their team of 70 employees.
Okay. We've taken a really deep dive here into how is 3D is leveraging this unique blend of VR, tactile feedback, instructional design principles, insights from neuroscience and storytelling, and simulation game design.
Quite a mix.
Based on the source material, they're creating immersive learning experiences that deliver some pretty compelling measurable results in safety and productivity in the demanding mining industry.
Yeah.
It's a powerful example of how integrating seemingly disparate disciplines from brain science to game design to safety science can fundamentally transform traditional training approaches, especially when the stakes are incredibly high.
Definitely. The key takeaway for me is that this isn't just about adopting fancy new technology for the sake of it.
Right, it's
It's built on a fundamental, science-backed understanding of how people learn effectively the power of muscle memory, the importance of emotional engagement for memory, the need for reflective practice, and the value of realistic, risk-free repetition. And the results they've shared in the sources, I mean, they are quite compelling, significant improvements in both production efficiency and training time while enhancing safety understanding.
You can really see how applying scientific principles of learning, combined with cutting-edge technologies specifically tailored to the task, can create training that is not only more effective, but in a field like mining, potentially life-saving.
Yeah.
Makes you wonder,
Yeah.
considering this specific blend of tactile VR, neuroscience, storytelling, and simulation game design used to tackle complex, dangerous tasks in mining, which involves physical skill, critical decision-making under pressure, and learning from real-world incidents, where else could this specific combination be applied to drastically improve training for other high-stakes jobs? Think beyond traditional heavy industries. What complex skills in what surprising fields could be mastered better, faster, and more safely with this kind of truly immersive, science-backed approach? It's a fascinating thought to mull over.